The future of AI agents and one of the most overlooked aspects in the AI agent world today is something very important, especially for people who are trying to be in the cutting or bleeding edge of technology and or building agentic frameworks. I think this feature is often overlooked and underutilized, and I wanted to cover it in this video today. Before we dive into this feature, which by the way is the CaptainAgent feature and the auto build feature by AG2, I want to give a bit of context, and then I will share why I think it's so important and powerful, and then I will show you some examples of stuff that I did with this feature. So in general, when speaking about agents, we have different states. I often say that the performance of the agentic frameworks is limited by the weakest link, and the weakest link at the moment, it's actually funny to say the weakest link, but it's actually the models themselves, so the performance of the models. So Claude 3.7 Sonnet, OpenAI 03, OpenAI's 01, GPT-4o. Those are the limiting factors in my opinion, in terms of yielding great output from agents, basically. So when looking about workflow automation or agents or use of LLMs, we have the chatbots, which are simple interfaces that we can communicate with the LLMs. We have workflows, so RPA workflows, which stand for robotic process automation, or workflows and automations that are built with Python. These are workflows that we basically build different logic, and we expect the machine to repeat that logic. So let's say crawl a website, fetch all H1s, organize them in a CSV, sort all headlines according to like in ABC order, and then generate content based on these headlines, whatever. So this can be a workflow. It's very stricted. It has many limitations, and you don't let the LLM roam freely and do anything on its own. The next step in the evolution, we have AI assistants or one-man show agents. So these are usually agents that have like a specific ability. It can be very broad, like the agents that I built the other day, and I published a video about the ultimate agent, which basically connects to Telegram, Trello, all G Suite, so Gmail, Google Calendar. It can download videos from YouTube. It can do transcription. It can search results in Google. It can scrape using Playwright, but still, it is only one agent. And when I wrote here AI assistants, I was referring to solutions such as Windsurf, for example. So Windsurf is an AI coding assistant, and basically I consider this part of Windsurf an AI agent, because what I can do here, I can discuss with Cascade, which is this function, and tell it exactly what it wants, and it can do a sequence of actions without me limiting it or generating the actions up front. So I saw somewhere like the definition of an agent. What was the definition? It was somewhat related to the fact that agents, in opposing to chatbots, they can do more than one action in a sequence. They can actually do a sequence, and based on the feedback from the outer environment, from the website, or mostly websites, or from the code, they can fix the route or do different things. So this is the AI assistants or one agents, and the next evolution is utilizing groups of agents, and this is where I think we will gain the biggest benefits. Obviously, as I said, the weakest link or the bottleneck is the model's performance, but as you guys probably know, the models are evolving very fast, and I don't like making predictions, but I believe that within 6 months or 12 months, the models will be way more capable, and we will be able to do way more exciting things with the models. Before we move forward, I invite you to subscribe to my newsletter, which is called the No Fluff newsletter. Basically, a newsletter in which I send stuff that I stumble upon or encounter during the week. I send it every Monday or Tuesday, just very short stuff. I try to make it as valuable and as useful as possible check it out at nofluff.online. And obviously, if you haven't subscribed to the YouTube channel, please do. Now, some theory before we move on, theory about the importance of division of labor. And this is an image. Oh, not a great representation, but this is an image which is related to Adam Smith. Adam Smith is one of the most famous economists. And basically, he wrote about the division of labor. And it is related to agentic frameworks and group chats. So Adam Smith, let me see if I can make this bigger. Yes, okay. So Adam Smith famously discussed division of labor in his in his very famous book, The Wealth of Nations, which was written in like almost 300 years ago. So it is one of the most important economic concepts, and his key observations include the following. So basically, Smith used the example of a pin factory to illustrate the concept. He described how manufacturing pins could be broken down into about 18 distinct operations with different workers specializing in each step. So it is similar to a workflow in which we have, let's say we want to generate an email, a cold email, so we can have 18 different agents. Each one is specializing in one specific step, like copywriting the headline, copywriting the text below the PS, copywriting the call to action, scraping the lead, verifying the emails, whatever. So for this specialization, he observed that workers could produce significantly more pins than if each worker individually made complete pins. So instead of having one agent doing the whole process of writing cold email, including finding the prospect, based on his theory, through building specialization, the results could be better. So moving on, he identified 3 main benefits of division of labor. So the first one is increased dexterity. Workers become more skilled and efficient at their specific task through repetition. Okay, imagine that you're writing, let's say you do the whole process of sourcing the leads, verifying the email, writing the copywriting for the cold email and sending it. So this is the whole process. Let's say it takes you, I don't know, 30 minutes. In opposing to an agent that would specialize only in writing the headline. So in 30 minutes, he can probably do 6 headlines. So over time, he can write way more headlines and is going to be more specialized. The next aspect is time saving. Eliminating the need to switch between different tasks reduces lost time. So in the factory of creating pins, let's say we had only one worker, so he would do like the first step in the process. I don't even know what is the first step in generating a pin. And then he would go about and do the second step and the third step, and just moving between the stations is going to waste a ton of time for him. Same thing in terms of, for us in this example of writing cold email. So if you're sending a cold email via Gmail, and you want to source the leads using Apollo, and you want to clean them up using a tool called No Bounce, or clean them up in waterfall verification process in Clay. So just switching between the softwares, logging in, etc., it is a waste of time and energy. Next is innovation, which is very important as well. Specialists are more likely to invent tools or machines to improve their specific operations. So again, let's say I'm only focusing on sourcing leads in opposing to sourcing the leads and writing the cold email. I'm going to start to find ways to automate the process of sourcing the leads. I'm going to constantly look how I can optimize sourcing the leads, finding better tools, writing the scripts, etc. So this is these are the 3 main benefits of division of labor. Now, Smith viewed division of labor as the primary driver of economic growth and increasing productivity. He argued that it was the key factor in creating the universal, I don't know even what is this word, basically. Great wealth, great wealth. He noted that division of labor is limited by the extent of the market. Larger markets allow for greater specialization, which makes sense. So Smith also recognized potential downsides, and this is also important, relating to building agentic workflows that consist of too many agents. So warning that extreme specialization might lead workers to become as stupid as and ignorant as it is possible for a human creature to become if their work would be reduced to very few simple operations. So this is not the only downside, but it is a downside. Also, with agents, you don't want to specialize them too much because it would also be harder to manage probably. And then they don't, it just switching the context between the tasks would would result in leakage in knowledge in the process. So the benefits of multiple agents: when they collaborate on a task rather than a single agent working alone, several key benefits emerge. And basically it's, let me see, it's like I said in the previous slide. So different agents can specialize in specific subtasks similar to human experts in different domains. Complex problems can be broken down into manageable components assigned to specialized agents, and each agent can be optimized for its particular function rather than being a generalist. We also have redundancy aspects. So if one agent fails or makes an error, others can compensate or provide corrections or criticism, feedback. Multiple agents analyzing the same input can cross-check results, improving accuracy, and this is something that is baked into the CaptainAgent, which I will show you in a moment. And the system becomes more resilient to individual agent failures. Obviously, it's also easier to debug, etc. So cognitive diversity, this is also very interesting and important. So different agents might approach problems using varied method or perspective. So first of all, you can provide each agent with different knowledge base, different track, and you can provide each agent with different tools. And more importantly, you can also provide each agent with a different model. So let's say I have a coding agent. I connect it to Claude 3.7 Sonnet. Let's say I have a strategy agent. I'm going to connect it to OpenAI 01. If I have a copywriting agent, I'm going to connect it to GPT-4o. So I want to save costs, and I also want to connect the agent to the most powerful LLM related to the task. So if we have a task of only verifying stuff, we don't even need to use a proprietary LLM such as the OpenAI or Claude. We can just as well connect it to Olama, like a local model, which is going to be completely free. And maybe we can use this just for verifying stuff. So like the most dumb agents can be connected to tiny models, and this can save time and save cost. Parallelization. So agents can work simultaneously, which can reduce the time needed to solve complex tasks, and obviously scalability and improved learning, because agents can interact with each other, which you will see in the moment in the example. They can transfer knowledge. I don't think there is competitive dynamics between agents just yet, but maybe later on. Okay, so I kind of alluded to this in a few minutes ago. How can we achieve this with agents? So different system prompts. So we can have all the agents with the same model, but with a different system prompt. Each agent will have a different description, and based on this, it will yield the different results. I'm sure that you noticed that whenever you adjust the prompt that you give to the LLM, you get different outputs. So sometimes just a slight adjustment in the system prompt can yield different results. Obviously, we can connect different models to different agents. We can fine-tune specific agents. We can connect different knowledge bases or different databases, and we can adjust the temperature. Now, this was just like an introduction to why I believe group of AI agents is going to become more and more important. And it's like, in organizations, I guess most of CEOs or most companies, they want to somewhat reduce the headcount or at least increase efficiency. And in order to increase efficiency, you need to find agents that are specific to the role that they are going to amplify or substitute. So this is why I believe agentic groups of agents is going to be is underutilized at the moment, but it's going to be the next big thing. Now, AG2, which is formerly known as autogen, have two very important, I would say, solutions in their repository, and one is auto build and the other one is CaptainAgent, and CaptainAgent basically has an auto build ability. What is a CaptainAgent? You can read about this in the blog. Let me see if I want to read anything here. Okay, so basically CaptainAgent, what it does, it gets a task from you as the user, and then it automatically, using auto build, it automatically generates a group chat, a team of agents. It can be 3 agents, 4 agents, 5 agents that are relevant to the task, and from there on they are going to start conducting a conversation between those agents, moving back and forth until they solve the task. And the cool thing about the CaptainAgent is that you don't need to define the agents up front. Because let's say you just want to use an agentic framework and you want to use a group chat, you can easily just define all the agents based on your knowledge. The thing is that this isn't dynamic. So if I would like to create a marketing team of agents, so I would hire a copywriter, SEO specialist, technical specialist, CMO, creative editor, media buyer, etc. So let's say we have 7 different roles in a small marketing team. For some tasks, some of them would be redundant, just create noise. So if I'm going to have them in the workflow, it's going to cost probably more. It might yield worse results. And it's also just basically a waste. So it's not precise. So this is the issue with a static group of agents. And CaptainAgent and the auto build function basically solve this, because based on each task, it generates the relevant agents, which is very, very important and very powerful. So I won't go over how to install CaptainAgent because you can find it here. I will obviously share the link in the video description. Let me show you another thing that I wanted to share is the system prompt. Why I think this is important? I think this is important for a few reasons. So first of all, whenever I use an open source tool constantly, I try to look under the hood because I want to understand how to make the most out of the tool. So this is just like a principle of mine. Furthermore, I did a few tests with CaptainAgent, and very often it didn't yield the results that I wanted. So since it didn't yield the results that I wanted to see what's going on under the hood in order to adjust my prompt or just align my expectations. So this is basically the system prompt of the auto build. So your role is basically you are a perfect manager of a group of advanced experts. When a task is assigned to you, first of all, you do an analysis of its constraints and conditions for completions, and you respond with a specific plan of how to solve the task. After that, you can solve the task in 2 ways. Delegate the resolution of tasks to other experts created by seeking a group of experts for help and derive conclusions, insights from the conversation summarization. And analysis and solve the task with your coding and language skills. Basically, this tool has 2 options. One is look in a library of agents and see if any relevant agents can assist in the task, or just generate the agent from scratch. And I will show you in a moment how it looks like. Some useful instructions. You have only one tool called Seek Experts Help. Provide an answer yourself after Seek Expert Help. You should suggest Python code in a Python coding block. And this is something very important, and I forgot to mention that baked into this feature, you also have code execution. And this is also very powerful because in opposing, for example, the agents that I mentioned that I built, the ultimate agent that has like really a ton of capabilities, but still I had to build all the tools up front. Tools are just functions, pieces of code that I know that whenever they are executed, I know exactly what I will get. No LLM is involved except for running the actual code. So calculation is a tool. Scraping email is a tool. So no text generation is involved from the LLM. It just you put input and you get output. It's a very deterministic process. So this is great because in opposing to creating a bunch of tools, in this feature, the team of agents, they actually generate code and they can execute the code. Now, when using code, you must indicate the script type in the code block. So if it's like a shell or a bash command, it mentions that it is a shell or bash command, because based on this, the executioner, the agent that executes the code, he knows how to approach this and how to execute the code. Do not suggest incomplete code which requires users to modify. Be clear about which step uses the code. If the code results indicate there is an error, fix the error and output the whole code again. If the error can be fixed or the task is not solved even after the code is executed successfully, analyze the problem, revisit your assumption. And I think I don't want to go more over this, but this just shows you how powerful this is. And I definitely suggest that if you start using the Captain Agent, check this out. Now, let's go back to the demo. So basically, I just created a very simple demo, as you can see here. Let me make this bigger. Okay, so this is the code. The most simple demonstration. So over here, we have only one agent. We don't build more agents. We only have one agent. And we ask it to crawl monday.com and summarize their unique selling proposition. When possible, use OCR. Just because I asked it in iterations prior to this, I asked it to scrape a few things, and it kind of had issues. I'm sure that if I would allow more turns, it would solve this, but it was becoming using more and more LLM API calls, and I just didn't want it to blow off my balance. So this is the system message, pretty simple. Now the interesting part is to show you how it looks like. So let's see. I didn't save everything. So let's start a new example from scratch. So let's decide about something else. Crawl. Let's plug again my website, the newsletter, and summarize the content. Let's do like this, just the most simple demonstrations, just so you see how it looks like, because it's pretty amazing. Okay, so crawl no fluff online and summarize the content of the homepage, even making it simpler. Now let's run this. Hopefully it will run. You know how it goes. It usually doesn't work when you do stuff. Yes, missing comma. Okay, now it's supposed to work. Let's clear this. Okay. Let's close this. And again, we have only the Captain agent. In a moment, you will see that it breaks down the task and then it generates agents, new agents based on the task. And then these agents are going to start a conversation among each other. If necessary, they are going, one of them is going to generate the code in order to solve this task. One of them is going to execute the code. And we also have one of them which is going to summarize the whole flow. So let's see. I think this is fine. Hopefully it will start running in a moment. Let's see if I covered everything that I wanted. Yeah, I think I covered everything. Yes, I think I covered everything. Okay, yes, it started. Okay, let's go back here. So starting a new chat. Expert. Okay, so this is the tool call. And then we are running auto build, which I showed you before. Building task, build a group of experts to summarize the content of a web page. Execution task, a task description. Crawl the homepage of my website or nofluff.online, summarize its content. The plan for solving the task is use a web scraping tool to access the homepage of the specified URL. Extract the main content, including headings, paragraphs, and any key information presented. Summarize the extracted content in concise manner. The output format, a brief summary of the homepage content in plain text. Constraints and conditions for completion. Ensure that the summary captures the main themes and information presented on the homepage. The summary should be clear and concise, ideally within 100 to 150 words. Now it is generating specific agents, so web scraping expert, Python programming expert, NLP expert, content analysis expert, and shell scripting expert. So this goes back to the division of labor. One agent could probably easily solve this, but 5 agents, I don't know if it's an overkill, but 5 agents are probably more likely to solve this because we need a Python programming expert, we need a content analysis expert. Now, the next step is preparing the system messages for each agent, then generating the description. For those of you who don't remember, the difference between a system message and the description is basically the system message is the instructions that you give the agent, and the description is how other agents view the agent. So let's say a system message is my internal operating system, and the description is how others perceive me. I don't know how, I don't have like a better way to make you memorize this, but basically remember the description is how you are, the agents are described externally, and system message is the actual instructions. Now we are creating the agents. Now the first task is to the web scraping agent, crawl the website and summarize it. Then the web scraping expert says, to accomplish the task, I'm going to do yada, yada, yada. Now it runs a Python code. So first of all, we need to pip install specific libraries for scraping. So Beautiful Soup and pip install scrape request. As you can see, this is a shell. This is a shell command. And then it wrote Python code, which is basically the Beautiful Soup, as you can see here. And this is amazing because it actually tells the execution agent exactly what is needed in order to run this code. So first of all, what libraries we need to install, and then the Python code. So parsing the HTML content. Then we have the execution of the code. As you can see here, you can see requirement already satisfied because these libraries are already, I already have them on my computer, and this is not in this environment. As you can see here, Beautiful Soup and request are already installed. Then we need to run the Python script. And this is what it yielded. Basically print homepage text, as you can see here. Code output, no fluff. Stay up to date about the latest and most important innovations in the AI space. Trusted by business owners and AI enthusiasts. And your #1 resource about data-driven automation, etc. This is the FAQ. Now, the content analysis expert said, based on the extracted content from the homepage, here's a summary. The NoFluff website is centered around delivering concise, actionable insights on AI agents, AI coding assistants, and no-code data-driven automations to help businesses thrive. Blah, blah, blah. Now, they are discussing between themselves, and no one answered the context analysis expert that something is missing. And then he said, since there have been no additional suggestions or modifications required, and the summary satisfies the original task requirement by capturing the main themes and key information from the homepage, I believe we have successfully completed the task. So we sent terminate. Terminate is like a safe word that basically says, let's terminate the process. Now we have the export agent, which summarizes the whole thing. This is baked into every CaptainAgent workflow. So it summarizes the task, the result, the reason for the result, if any errors or issues arose in the conversation, if there is a need to double check. And this is crazy useful, because let's say I would have created a more complex demand, and so we would have had errors. And whenever we have, and this summarizer agent is reading the context of the conversation, and whenever it sees results, it mentions them here. And then if we have a need to double check, he usually says yes. And based on this, the team of agents generate another iteration and try to solve what went wrong in the first iteration. And here's the summary, and that's pretty much it. We have the bottom line. The conversation history involved a group of experts tasked with scrolling the homepage of nofluff.online and summarizing its content. This is the initial task, the expert's plan, this is the attempt, and this is the result. And that's it. And this was just a simple representation of how powerful the CaptainAgent and the auto build feature is. I think I covered everything that I wanted to cover. Yes. So before we conclude, let me make this a bit smaller. So before we conclude, again, I invite you to subscribe to the channel, leave a comment below with your feedback, join the No Fluff newsletter, and if you need any help with strategy or implementing automations in your business, feel free to reach out via LinkedIn or via this email. Quick summary. Group chats of agents, I believe, are underutilized. They are very powerful, especially because, as we discussed, the division of labor. If you build specialized agents, you can expect better output. This is often overlooked. One of the issues with group chats at the moment is that they are static. So you need to come up with which agents you want to use and the system message and everything. And this is a bit tedious and also very often not accurate. And it isn't self-correcting, in opposing to CaptainAgent, which also is building the group dynamically. If there is an issue between iterations, I forgot to mention this. So if there is an issue between iterations or a new task emerges, it adjusts the team. It generates new agents based on the new task or based on the feedback from the previous error. So this is very powerful. Yeah, I guess that's pretty much it. Dynamic group chats for agents, I believe, are underutilized and very important. I hope you enjoyed this video, and until next time, keep on automating.